The quantitative measurement program measures the absorbance at a single wavelength for a set of samples with known concentrations to create a calibration curve. The absorbance of samples with unknown concentrations are then measured and their concentrations determined from the previously obtained calibration curve. To set up the measurement parameters, select the parameter icon in the menu bar or click Measure Parameters. The parameters can be switched between basic and advanced mode. In basic mode, the settings are automatically specified with certain parameter combinations. In advanced mode, each parameter is specified individually. To show the breadth of the settings, we will proceed in advanced mode. There are three quantitative method options. The no-base method uses the peak absorbance at a single wavelength. The one-point base uses the peak and baseline wavelengths, and the two-point wavelength uses 3 wavelengths for samples with inclined baselines. The bandwidth determines how much light reaches the sample. The smaller the bandwidth, the less light throughput, and the lower the signal to noise, but you can achieve better peak resolution. If you are using a V730, the bandwidth remains fixed at 1 nanometer. The V750, 760, 770, and 780 all allow for the bandwidth to be varied, and if you are using one of these instruments, a 2 nanometer bandwidth is a good starting point. The response is the time spent accumulating photometric or absorbance values. The response time can be increased to obtain better signal-to-noise ratios for samples with small absorbances. If basic mode has been selected, the optimum response is automatically determined from the specified bandwidth. The number of cycles allows you to specify the number of sample measurements to be obtained without having to manually start each measurement. In the Calibration Graph tab, you can specify the quantitation method and concentration units used for creating the calibration curve. There are 10 equations available: proportional, linear, quadratic, cubic, line segment, spline, and logistic. The quadratic, cubic, and line segment methods can also be selected to pass through the origin. In basic mode, only proportional and linear methods can be selected. If the calibration curve is created using either the linear, quadratic, or cubic methods, the precision calculation box can be checked, which will display a 95% confidence interval on the calibration curve graph and provide the detection and quantitation limits, which are displayed in the Calibration Information tab. You can also enter your own values for the slope and y-intercept by selecting the Enter Equation and Coefficients option. There are numerous concentration unit options, however you can also enter your own concentration units if they do not appear in the drop-down list. In advanced mode, the Correction tab lets you select whether to correct your absorbance data with a baseline, blank, or a dark correction. The dark correction measures the absorbance with the beam path blocked by a shielding plate. It is recommended for samples with high absorbances and cannot be selected when in basic mode. The dilution rate correction corrects the measured photometric value of a diluted sample to give the equivalent photometric value for an undiluted sample. In the Control tab, you can specify the changeover wavelength. The D2 and tungsten halogen lamps switch at 340 nanometers. If your peak absorbance is at 340 nanometers, you can move that changeover wavelength between 330 and 350 nanometers. You can also specify if you wish to use only the D2 or halogen lamp, or choose an external light source. The Sheet tab is used to set the layout for the calibration and quantitation sheets. The Information tab allows you to populate the desired fields such as method, comment, and user. These comments can also be displayed in the Comments dialog box before the sample measurement. All information provided here can later be viewed in the Information tab in Spectra Analysis. The Data tab allows you to select whether to automatically save your data, as well as to specify which folder to save it to in the format the file is saved as. The data can be automatically exported as either a text or CSV file. If a sequence has previously been set up, you can select the quantitation or calibration and quantitation sequence file here. A sequence performs the baseline, standard, and sample measurements automatically. This operation can be performed by clicking the Sequence Tool button in the icon toolbar. You can also choose to save your measurement parameters as well as open previously saved parameter files. To begin creating a calibration curve, place a cell filled with a solvent into the cell holder and select the blank icon in the menu toolbar. Then select Measure. The absorbance value at the peak wavelength specified will be automatically entered in the calibration sheet under the peak wavelength column in the blank row. Now place the first standard sample with a known concentration in the sample side cell holder and verify the number 1 row is marked with an asterisk. Select the sample measurement icon in the toolbar. Once the absorbance value has been obtained, it will populate both the absorbance and peak wavelength columns for the sample number 1 row. Both the absorbance and peak wavelength values are corrected for the blank absorbance. The peak wavelength column is the rounded absorbance value. The sample name, comment, and concentration can be entered either prior to the measurement or after. A new row is added for subsequent standard sample measurements. To run the next standard sample, place the cell in the cell holder and select the sample measurement icon. If you do not wish to use one of the measurements in the calibration curve, deselect the Use box. If you wish to remeasure a specific standard, select the row number to be remeasured, confirming that an asterisk is next to the row number, and select the sample measurement icon. Continue this process until all standards have been measured and the calibration curve is completed. To view the calibration curve equation, select the Calibration Information tab at the top of the graph. Here the peak method and equation are displayed, along with the equation coefficients and the correlation and determination coefficients. The calibration curve can also be saved by selecting File, Save Parameters, Calibration. To perform the quantitative measurements on a set of samples with unknown concentrations, double-click the quantitation sheet or select the quantitation icon. Place the sample with an unknown concentration into the sample side cell holder and select the sample measurement icon. The measured absorbance value will then be automatically entered into the absorbance and peak wavelength columns for sample 1, along with the concentration calculated using the previously created calibration curve. Repeat the procedure for the remaining samples having unknown concentrations. The quantitative results can be saved by going to File, Save As, or selecting the Save icon in the toolbar. You can also use a previously created calibration curve. To do so, click the Open Parameters icon and select the calibration curve you wish to use.